Hey everyone, I'm Natalie. As you said, I work at a new company called Interpret based in Christchurch. This morning I'm going to introduce you to a project I've been working on for a wee while, looking at a way to use Python to simplify the production of maps for local councils. I'll run you through some of the project background, some of the software I used, and a couple of the specifics of the map production before looking at the problems and benefits of this sort of a solution. So one of the things councils do regularly is produce LIMs. LIM stands for Land Information Memorandum. These are legal documents that collate all the information a council holds on a property. People usually purchase a LIM when they buy a house, as well as information on things like rates and building licenses. They get maps showing water, sewage and drainage plans, locations of protected trees, and any building consents relating to the property. As you can imagine, there's quite a lot of information in these. It's sourced from a variety of different spatial and non-spatial databases. The processes for creating these LIMs are quite simple. They follow a logical set of rules, but all the same, it takes a lot of time to manually sort through these databases and get all the appropriate information. So when I saw the maps being produced this way, I thought this is a prime candidate for automation. The council staff who create these LIMs are not necessarily interested in programming or in the nitty-gritty of map production. So we needed a process that was suitable for people to use without in-depth knowledge of the data. To be useful, it had to be a sort of click-and-go application. I decided to use Python to build an automatic mapping solution that would take some simple user input and produce professional quality maps working within the specified LIM format. All of this was pretty new to me. I'm not a programmer at all. In fact, I work as a GIS analyst. GIS, or Geographic Information Systems, is all about working with spatial information to try and understand what stuff happens where and why, and to find ways to communicate that information effectively. I'm also really interested in finding ways to work smarter. The main GIS software we use is called ArcMap. I don't know if any of you guys use ArcMap. Yeah, a few people, excellent. The picture at the bottom of the slide is a screenshot from one of our components of ArcMap called Model Builder. The blue circles are inputs, the orange hexagon is an iterator, the green circles are intermediate steps, and the yellow boxes are tools called geoprocessors. Model Builder is essentially a way of stringing these geoprocessors together so that we don't have to run the same series of events by hand time and time again. So it's a visual way of composing a program. A few years ago, the company that produced ArcMap switched to using Python as their default programming language. So all the processes and the interactions defined in this model builder example could also be viewed as a Python script. Python 2.7 is included with all installations of ArcMap, along with the ArcPy module, which exposes almost all of these yellow geoprocessing tools to Python directly. Geoprocessing is the backbone of GIS. It's a term that encompasses a whole pile of data and spatial manipulation, such as buffering a polygon, working out how many points fall within an area, or selecting the lines within a set distance of a feature. The two tools I used very frequently in this application were the Select by Attribute and the Select by Location tools. They both do pretty much what you'd expect. The Select by Attribute tool selects all the data within a specified layer that returns true when evaluated against the expression in the parameters. In this case, we have a layer called Houses with an attribute called Address, and we want to select only the house that has the address 32 Main Street. Select by Location selects features in a layer dependent on their spatial relationships to features in another layer. In this example, I want to select all the zones that intersect my house in a layer by itself. So this line of code will allow me to determine which, if any, zones intersect it. I wanted to build a super lightweight application that didn't require too much installation or configuration and didn't take up too much of the host computer's CPU. So I decided to use only modules that would be included in every installation of Python I'd come across. These modules include Web Browser, tkinter, Time, OS, and of course, ArcPy. The application runs off a single Python script referencing a single map document. The script uses the parameters entered by the user to find the correct property and then exports a series of maps from the map document based on the rules specified in the code. I'll show you each of these segments in a little more detail. The AutoLIM application has about 700 lines of code. Of this, around 400 is the guts of the program that actually makes the maps. The first section of the code is all about generating the interface and setting up some of the background data. It also generates a list of the addresses in the database to populate the autocomplete box where the user inputs the target address. Once the user has put in all the necessary information, the program sets up the map layers and makes sure they all display using the correct symbology. It also sources some of the key information about the LIM property, such as the correctly formatted address, the property area, and the legal descriptions. This is where all the geoprocessing housekeeping occurs, ensuring that the spatial layers and the variables in the code are correctly defined. Each of the maps in the final LIM document is created by a separate module. The code works its way through a list of these modules. Each one turns on the appropriate layers for that map, and if the map is required for the LIM, exports it to a PDF. These PDFs are all appended into a single document. Each module also updates the progress bar by one step so that the user can tell how far the application has moved through the mapping process. This is the ArcMap document that holds all the spatial information. In my day-to-day work, I normally do most of my work inside map documents like this. However, the team that makes the LIMs don't necessarily know how to use ArcMap. So the code never actually opens a map document, it merely references it using ArcPy. The map layout defines how the output maps will look. I've set it up here to show the council's logo, a scale, today's date, and a window of map surface. The text elements include things like the address, the reference number, disclaimers, and the type of map being produced. These are all updated dynamically in the script. The core layers are things like the address points and the cadastral boundaries. They're always left on and so appear on every map. Whereas the rest of the layers are group layers. Each map producing module has a set of layers that is needed to produce the map. Having them grouped like this means that the code only has to switch on the top level layer rather than each of the sub-level layers. For example, you can see here under the farming group layer, there are 4 data layers. If I want to make a map showing the property in relation to farming activities, all I have to do is turn on the top level farming layer. Some types of maps are needed no matter what. For example, maps showing the location of water and sewerage services, or aerial maps, appear in every LIM document. The modules that produce these maps will always run, and so will always produce a PDF output. The basic workflow is for the module to find the address of the property, center the map, and then set the scale. The exact scale depends on the size of the property, whether it's urban or rural, and the type of map being produced. The appropriate layers are then switched on, and the resulting layout is exported to PDF. This is a map of the utilities, sewage, water, and drains for a property. You might notice that there isn't a legend showing what each of the utility symbols is. That's because I've created a static PDF of the full utilities legend sitting in the appropriate data, in the application data. This is appended to the output PDF as well. So, as well as generating maps from this map document, I can also append any document already in the council's filing system. This is a map showing the aerial imagery underneath the property boundaries and some textual information. Aerials are another one of the always-on modules, but the images that display in the map document are scale-dependent. These layers turn on and off automatically to make sure that the clearest and most up-to-date aerial imagery is used. Sometimes maps only need to be produced if a certain set of criteria are met. This diagram is almost the same as the one I just showed you, except that before exporting the layout to a PDF, the module checks to see if the property fulfills a series of criteria. If not, the rest of the module is skipped. A variation on this theme is that sometimes the maps are produced slightly differently, depending on the outcome of the conditional statement. For example, you might want to create a map showing the location of sensitive waterways near a property. We could say that households need to be aware of waterways within 100 metres. So to decide if the map is needed, we first turn on the layer of waterways, then we might select all the waterways within 100 metres of the property, and then do a count to see if anything in the waterways layer is selected. If this count is greater than 0, then we create the map. Sometimes we need to do multiple spatial selections to get the right result. In this case, we want to know if there are any protected trees on the main property, shown in grey, or in any of the neighbouring properties. We have to select the main property, then select the properties touching it, and then select the trees that fall within these properties. A count of selected features in the trees layer will tell us whether to create the map or not. The precise way in which we select the properties that are counted as neighbours can change the outcome. If we select those that share an edge with the grey property, then we get this result, and you can see there are no trees. If instead we select those that intersect the main property, then we pick up the polygon that touches its corner, which has a tree in it. If we select those parcels within a set distance, such as 5 metres of the main property, then this is what we see. The back property is selected because its driveway passes close to the main property, even though the main section of that property is further than 5 metres away. All of these give quite a different result to simply selecting the tree nearest to the main property. In another example, we might want to know if a property falls within a set hazard zone. The basic methodology to determine this is to select the property and then select the hazard zone that intersects it. Once again, though, we have to decide how to determine the intersect. This particular property is certainly within the blue hazard zone, but depending on how we set our selections, it may or may not be counted as being within the orange zone. The correct answer to these sorts of questions really depends on the client. Generally, the people responsible for the LIMs will know what sort of result they want from each situation, so my job was simply to convert this information to rules that the computer could understand. This is one example of a map document produced by a conditional rule. The shaded areas show resource consents on properties. We're only interested in resource consents that are on our main property or on its direct neighbours. So this map is only produced if consents are found on any of these. The application also spits out a list of the neighbouring properties and the consents found on each of them. So I used tkinter to make the GUI. It's certainly not the prettiest, but as I mentioned, I wanted to use only modules that shipped with Python. The idea was to make the interface as simple, clean, and as intuitive as possible. There are 3 things the user needs to put in. Firstly, an address. This uses an autocomplete functionality sourced from a list of all the address points within the database. Secondly, the user selects whether a property is urban or rural. This is used to select the correct legend and also to set the scale for the map output. Urban properties are mapped at a slightly more zoomed-in scale than rural properties. There's a space for the user to enter a LIM ID. This appears on all the maps and as part of the file name. The user can choose where to save the output maps before clicking the Create Maps button. This button grays out and is disabled, and the progress bar is started, which updates as the program runs. Once completed, the application needed to be packaged in such a way so that the code was inaccessible to the client. This was partly to protect the intellectual property in the code, but also to make sure no one would open the code, make changes, and then complain it didn't work anymore. I compiled the .py to a .pyc using a wrapper script, and then used a small program called bat.exe to generate the executable. We could then remove the Py script and be left with a working application. To run the application, the client needed these 2 files, the .pyc and the executable, and additionally, the ArcGIS map document, and a folder containing all the bits and pieces used to build and run the application. This folder was for things like graphics for the user interface, static PDFs, and the help documentation. The executable file was 62 kilobytes, and the completed set of files was only 4.5 megabytes. The client also needed to have ArcMap installed for the application to work. There were some risks involved in packaging the data like this, Someone who was a little tech savvy and determined could crack the compiled code, but that was a risk we decided to take. So when I started this project, I was very new to Python, and especially to working with ArcPy. This meant that the program evolved as I learned, so some of the code probably isn't written in the most sensible way. I spent a lot of the development time working on the council's local system. This had its own challenges. For example, I had to work out how to source some maps from a document storage system called TRIM. In the end, the only way I could work out how to do this was to open the documents using web browser, which resulted in a temporary copy being stored locally. I could then use os.walker to check every file in the directory to locate the correct one and append that to the PDF document. If anyone has a better way, please come and tell me. We had a lot of challenges to do with knowing exactly what the client needed. The end scope of the project was a bit different to the initial brief, which I think made the application more useful, but was very frustrating to work with. We had a lot of examples where we'd get, oh, can you just make some little change? Which wasn't hard, but would have been a lot tidier and easier had they been included in the original scope rather than being bolted on later. On a related note, it was difficult to optimize the running of the code, to reduce the total map production time down to just a few minutes. Part of this was because the geoprocessing operations necessarily take a wee while, but I'm sure that there are some improvements that could be made by streamlining the code. The main benefits seen from implementing this system was that the time taken to make the maps reduced from about 20 minutes to around 2. There was also a reduced capacity for human error and inconsistency. When maps are made by hand, inevitably some layers get incorrectly left on or some labels are printed wrong. When produced automatically, the maps are the same each time and so are consistent and hopefully correct as long as the underlying map document isn't changed. Finally, one benefit that isn't immediately obvious is that we can generate some basic reporting from the application. Just before the script terminates, it writes some output to a CSV file, which shows the address, the LIM ID number, the time and date, the length of processing time, and if any errors were recorded. This allows people at the council to track which LIMs have been produced and allows us to see how often they are using the application. It can also potentially be used to help diagnose errors. So where to from here? It's a funny kind of a question to be asking someone who makes maps. This type of automated mapping application can be used anywhere where people make maps using essentially the same series of clicks each time. The outputs can be fully customized as long as the client can identify a series of rules that our data needs to follow. If you want to find out any more, you're welcome to email me, visit our website, or come and talk to me during the conference. Thank you for your time.